we're going to be doing today is we're going to be applying slope, right? We're going to be making accurate graphs of lines where they have a point and a slope. So all we're going to be doing is drawing lines that go through points and applying the slopes. The very first thing I'd like us to do is I'd like you to plot the point right here. Plot the point 0, 2. So we're going to plot the point 0, 2 right there. That is the point 0, 2. That is your x coordinate. That is your y coordinate. The next thing we're going to do is we're going to look at the slope. Just remember, the slope always refers to the rise over the run. So what is our rise? It's going down 1 and over 3. So you're going to go down 1 and you're going to go over 3 to the right. So from this point, you're going to go down 1 and over 3. Down 1 over 3 would put me right about here, but I ran out of room. So what I also can do, if I can go down 1 and over 3 to the right, I can also go up 1, but over 3 to the left. There you go. Now what I'd like you all to do is just draw a line carefully through those points. Draw a line through those points. All right, what I'm going to do now is I'm going to shade in. I want you to guys see the slope. So right here, I want you guys to focus in on this triangle that I'm shading right in there. I'm going to shade in this triangle. Hopefully you guys can see the triangle that I'm shading in. And each time, what is happening with this triangle here and this triangle right there? It goes down 1 and it goes over 3. This goes down 1 and it goes over 3. This section right here is called the rise. This section is called the run. So it's going down 1 and over 3. And notice, it's called a constant rate of change. So it continually goes down 1, over 3, down 1, over 3. Can you see how this would continue even though I didn't quite finish it here? It will continue to do what? Go down 1 and over 3. So that's what I'd like you to do. Plot the point. Plot the points, down 1 over 3, draw your line, and then what I want you to shade in shade in those triangles so that your brain understands that these are the rise and the run. That's what it is of the graph. All right, moving on. I'm going to go ahead and look at problem number 8. What's the first thing that I'm going to do? Plot the point. Plot the point correctly, so I'm going to go ahead and plot this point. That's my x coordinate, that's my y coordinate. So I'm going to go over 1 to the right and up 4. I'm going to put a point. Now this says it has a slope of 2. Now what fraction would that be? A 2 over a 1. Now what does the 2 represent? That represents the rise, and the 1 represents the run. So basically I'm going to go up 2 units and over 1 unit to the right. So let's try it. Up 2 over 1. So that'd be somewhere right in here, right? Since I can't go up 2 and over 1, I can still go down 2 but over 1 to the left. Down 2 over 1 to the left. Down 2 over 1 to the left. Now, if I say you go down and you have to go to the left, going down means it's negative. Going to the left means it's negative. What's a negative divided by a negative? A negative divided by a negative becomes a positive. That's why it will still work. So how could you check to see if you did it correctly? Well, let's check it. Up 2 over 1. Up 2 over 1. Up 2 over 1. It works. So go ahead and draw on your line. Draw a nice straight line. Okay? And then I want you to shade in your stairs. Look, it goes up 2 over 1. Up 2 over 1. Up 2 over 1. It keeps doing that. That's the pattern. I'm going to change my color. There we go. Trying. I do these problems with you because I'm attempting to let you guys see the pattern. This is the rise. This section right here is the run. It goes up 2 and over 1. Go ahead and shade that in. All right. of 0, that means you are going to have a horizontal line. So that will be a horizontal line. So I'm just going to plot the point. -2, -5. 2, 3, 4. Put a point right there. And what do I have to draw through that point? I got to draw a horizontal line through that point. I'll try to make sure it goes right there perfectly. Man, it didn't work out that way. Hold on, try one more time. There we go. There's a horizontal line through that point. Notice, is there any rise or run? No. Basically, that's a flat line. Person right there. All right? That's the easiest. There's no stairs for him to go up and over, right? You just walk straight across that line. All right? That's why it's a 0 slope. By the way, the equation that would go with this line would be y equals -5. That would be the equation. If I said, hey, what equation goes with that line? You'd say y equals -5. If you don't believe me, go right here, type in y equals -5 in your graphing calculator. I'm going to hit zoom standard. There's your line, y equals -5. If I said y equal 2, you still have a slope of 0, but where would the y be? Right there at 2. So anytime you guys see that, that's what I want you to recognize. So that's slope of 0, pretty easy. Let's go down here. Ooh, another easy slope. Number 10, what's our slope for number 10? 1. What does that mean? That means the rise over the run is what? So go ahead and say, Jordan. 1/1. That means you go up 1 and over 1. So we're going to plot this point. -1, 2, 3, 4, up. 1, 2, 3, 4, 5, 6. What did I do first? I plotted my x-coordinate and my y-coordinate for this ordered pair. Now from here, what do I have to apply? I apply a 1-to-1 slope. Up 1, up 1, uh-oh, I ran out of room. If I can't go up 1 and over 1, I can still go down 1, over 1 to the left. Down 1, over 1 to the left. Down 1, over 1 to the left. There's your slope. Right there. There's your slope. Now, make your stairs. I want you to recognize the difference between a slope of 1 and a slope of 2. This one goes up 1 and over 1, and the slope of 2 looked like it went what? Up 2 and over 1. See the difference there. All right now. All right. Go ahead and begin. Dalton's going to start our problem for us. What's he going to do first? He better plot -3, 0. We will say agree or disagree. I agree. -3, 0. Now, what's the next thing that he's going to write neatly onto the paper? Rise over run. So there he's going to write rise over run. No, that's not what he did. Okay, hold on. Here's what I was expecting you to do. Hold on. Let me take over here and put equals. That's the rise over the run. Now, he did go down -3 units, and he went over to the right 4 units, and he went down 1, 2, 3, and over 1, 2, 3, 4, and he put a point there, and he put a point there. That is correct. Okay? So from right here, he would have to go down how many more? 3. 1, 2, 3. You have to go over 1, 2, 3. I'm going to make an estimate, Dalton. That's an estimate. Now, what I'd like you to do, Dalton, is I would like you, I've given you a line now, okay? Can you go ahead and draw in? Go ahead. You're under control. You have the control. I would start from the bottom and work your way up. That's what I would do. So go, by the way, let go the pen. Let go. There you go. Go from the bottom point all the way up through those other points. It makes it easier. There you go. All the way through, and that looks good. Good job. Now, the next thing, let go. Good. Next thing we're going to do is we're going to shade in. Check this out. This triangle is going to be a little bit larger. You see right there? Mm-hmm. Yeah, that's going way further down. It's a lot harder to shade in because this was what? Up 1 and over 1. What was this one? It went how far down? It went down 3 units, and then it went over 4 units. What does the negative 3 represent? That represents the rise. What does the 4 represent? The run. There you go. Good job, Dalton. Let's go switch on. All right, we go right over here. We're going to do problem number 12. Okay, I'm going to change it to blue. All right, and we have an x coordinate and a y coordinate. Let's leave your charge. Go ahead. What are we going to do first?
We're going to plot the 0, 0.
0, 0. Where is 0, 0? What do we call 0?
In the origin.
That's right, the origin. Go ahead and do that. All right, that's a big old point right there. All right, good job. She's plotted a point. Now, what are you going to do next, Leslie, if you follow my pattern?
You are going to do rise over run.
Good. Write that down, nice and neat. Very nice. I like it. Equals? All right, now, what is our rise?
1.
So it means you're going to make a little arrow going up 1. Make a little arrow. Up there, up, good, over. Yeah, over 5 to the right, good. Now go ahead and go from there. Go from your origin. She's going to go up 1 and over 5. So basically what she did right here, hold on. She went up 1 and she went over 1, 2, 3, 4, 5, good. Oh, she ran out of room. Leslie, what did you do from right there?
You can go down 1 over 5.
To the
left.
Good, right. Down 1 and over 5 to the left. Right there, perfect. All right, good job. Now that she's done that, so now it still works, right? Up 1 over 5, up 1 over 5. So I'm going to switch to a line. Go ahead and draw that line from points all the way through those other points. There we go. All right. Not bad, not bad. Give me one more shot. Go ahead, try it again. Good, excellent, perfect, good job. All right, so here's the triangle that I want you guys to shade in. Did you guys see how easy these stairs would be to walk on? Be really easy stairs to walk up, because all you have to do is step up and you walk over, step up, walk over. Okay? So right now, what do we call? I'm gonna Leslie, help me out here. These sections right here and here. What am I going to call that section? What do we call that? That's a 1, which represents the rise. And this right here is the section called the run, and that run is equal to 5 units. Good job. All right. So what you're going to be expected to know how to do, not just today, but for the rest of your life. Okay? All right, we're going to be getting our journals out now because we have some concepts that we need to write down. On number 13, I'm going to write down what you need to write down in your journal. I'm going to write down parallel lines. You don't have to make a whole bunch of noise here. Parallel lines have the same something. So I'm going to draw a set of parallel lines, okay? Lines that are parallel never intersect. They go up at the exact same rate, okay? Or they go down at the exact same rate. So here's another set of parallel lines right here. There's a set of parallel lines. So what do you guys think? What would be a phrase that pays? Parallel lines have the same. What do you think? That's right. Parallel lines have the same slope. All right. So if I have two lines that are perfectly flat, like they have a 0 slope, that means both of these lines have a 0 slope. If I have two lines that are undefined, those are a set of parallel lines. So you can have parallel lines that are going up from left to right. You can have parallel lines that are undefined, parallel lines that are negative, positive, and 0. So you can have parallel lines all over the place. But what is their slope going to be? Their slope is going to be the same. If this is undefined, then this one's. If that's positive, then that's, and it's the same rate. So if that's like 1 over 5, then that's 1 over 5. If that's down 1 over 5, then that's down 1 over 5. Okay, so that's the concept you got to have in your journal. You got to know that if it says these lines are parallel, that means they have the same slope. Okay, here we go. There is a symbol to represent parallel lines. This is the symbol. So if it says, like if I say line AB, and then you see it's double L parallel to CD, That looks like a pair of L's. Say pair of L's really fast.
Parallel.
Say pair of L's. Parallel. You see a pair of L's, this symbol means parallel. So this means line AB is parallel to CD. Okay? So right now, that's what you need to write down in your drill. That's the symbol for parallel. That means AB is parallel to line CD. So here we go. Let's look at this one. It says, we got to graph a line that contains B. So let's plot B. -4 and 2. So we're going to plot -4 and a +2. We're going to label that point B. Okay? And it says it's parallel to F and G. Let's switch colors here. So right now, we're going to graph. Ooh, by the way, does anybody know what graph symbol of FG represents?
Zero.
No? What does that look like that's a drawing of? No? Okay, it is a zero slope. But it's a zero slope of what? Of a... Yes! This symbol means line. This means, instead of having to write line F, G, instead of writing the word line F, G, if I put a little arrow going in both directions over the F, G, guess what that means? That means line. Good. Alright, so it has a what? 0 and a -3, which is right here. Could you please label that point F? And it has 4 and a -2, right here. And label that point G. Okay? So that's what I want you to do. We're going to label F and G. And now we're going to find the slope between F and G. So let's think about this. Let's look at the rise over the run. Let's figure out what that is. How much does it go up? 1. How much does it go over? 4. So what is the slope of FG? Yeah, that's the slope. So the slope of FG is 1/4. And what did I say? Parallel lines have the same?
Line.
Nope. Same slope. So what slope will I have to apply from right here? I still have to go do what? Go up 1 and over 4. Up 1 and over 4. So right here, what I'm going to do, I'm going to go down 1 and over 4 to the left. I'm going to make a nice, beautiful red line going through all of those points, just like that. Good job. There we go. So there's my line. Here's my other line right here. Going through all of those as best as I can. There we go. These lines are parallel to each other. How do we prove that they're parallel to each other? Because parallel lines have the same. That's right. I'm saying it over and over and over again. I'm trying to drill it into your brains. So my proof right here is not just doing the algebra, but also just being able to draw the graphs and show and represent the same rise to run ratio. It goes up 1/4. That goes up 1/4. That goes up 1/4. So those are parallel lines. Okay? Okay, in your journal, we have a new word that you have to worry about. Perpendicular. So right now, guys, I'm going to go over here. I'm going to write a concept about perpendicular. So right now, here's what I want you guys to write down. Perpendicular. So write that big old long word called perpendicular. Perpendicular lines form a 90-degree angle and have slopes that are negative reciprocals. Not done yet. Their products always equal -1. give you guys a symbol. I'm going to give you a symbol that means perpendicular. If I write this symbol down, that's saving you time and energy from having to write the word perpendicular. This is the symbol. That is the symbol. Basically, it looks like an upside down T. Okay, so how do you write it? You just put an upside down T. Notice, what kind of angle does that look like that is right there? 90 degrees. That's your symbol for perpendicular. So if I say that, that means what? That means perpendicular. Okay? So right now, I'm going to give you guys some examples of perpendicular slopes. Okay? Here's some examples. So right now, examples of, I'm going to put upside down T and the word slopes. What does that mean? Examples of perpendicular slopes. So give me a slope, any slope. Go ahead.
Well,
give me a slope, any slope. 1 over 4. We're down 1 over 4. Now we're going to tell you what the perpendicular slope is of a 1 over 4. Now I said that the perpendicular slopes are this thing called what? Negative reciprocal. I'm going to explain to you what that means now. A negative reciprocal means you take the numbers and you make the reciprocal of them, and then you apply a negative. So the perpendicular slope of 1 over 4 is negative 4 over 1, also known as just negative 4. Now watch. If I take 1 over 4 and I multiply it to negative 4 over 1, how do we multiply fractions? Numerator times numerator and denominator times denominator. So that gives us negative 4 over 4, which reduces to a negative 1. What are the products of perpendicular slopes always equal to? Negative 1. So there's your first example of a perpendicular slope. This slope is perpendicular to this slope. All right, here we go. Give me another slope, Devon. Another slope. Give me another slope. 10 over 5, that reduces to 2 over 1, so I'll do 2 over 1. All right, 2, also known as 2 over 1, is perpendicular to the slope known as negative 1 over 2. All right, so 2 over 1 is perpendicular to negative 1 over 2. So watch what happens. When I take 2 over 1 and I multiply it to negative 1 over 2, I get negative 2 over 2, which is still equal to a negative 1. Okay, so these slopes right here are perpendicular. I'll do a couple more here. Here we go. 2 over 3. Ooh, what did I say? Negative 2 over 3. What's negative 2 over 3 perpendicular to?
Huh?
Go ahead.
3 over 2.
Yes, I heard you. Positive 3 over 2. So if that's a negative, then this has to be a positive. If we start with a positive, then we end up with a negative. This starts with a positive, we end up with a. This starts negative, we have. That's where the word negative reciprocal comes in. Okay, one of them is going to be negative, one of them is going to be positive. So here we go. We take negative 2/3. We multiply it to positive 3 over 2, and you get negative 6 over 6, which once again is a negative 1. Hopefully this is enough for you guys to understand what negative reciprocals and perpendicular slopes are. Okay, so let's go to our problem now. We're going to take this information, we're going to go over to our problem. So here we go. We have to draw in a line that contains negative 3, 0. So plot negative 3, 0. Please stop making that noise. Thank you. And it's perpendicular to what? E and K. So here we go. We're gonna draw what EK looks like. So EK, what is going to be the slope? That's what we're going to figure out right now. We're going to figure out EK's rise over run. We're going to figure out the rise to the run. So here we go. Negative 2, 4. Negative 2, 4. And what? 2, negative 2. Over 2, down, negative 2. So this is E, everybody. This is E, and this is K. So we got to draw a line going through those 2 points. So here we go. There's E and K right there. That's EK. Now, I'm going to figure out how far it goes down and how far it goes over. All right, here we go. From here, we're going to go down a certain amount, and we have to go over a certain amount. So if we're going down, what does that mean about our slope? Go down. Slope is negative. So how much? How much do I go down before I go over to the right positive? Let's think about it.
6.
1, 2, 3, 4, 5, 6. You're right, put negative 6. And how much do we go over? 1,
4.
2, 3, 4. Good, put 4. Now that can be reduced, everybody, as negative 3 over 2. So here's what I want you guys to do. Put the slope of EK is negative 3 over 2. That's your slope. Let's check it. Down 3 over 2. Down 3 over 2. It works. So here we go. Negative 3 over 2 is perpendicular to what new slope? Negative 3 over 2 would be perpendicular. That's right. Positive 2 over 3. So what is our new perpendicular slope? Our new perpendicular slope is positive 2 over 3. So right here, what am I going to do? I'm going to go up 2 and over 1, 2, 3, and put a point. Up 2 and over 3, and put a point. Now I'm going to draw it in. Here we go. Drawing it in. The best of my ability. Right there. Drawing that in. Can I do a better job there? There we go. Alright. Now, does it look like these two lines form a 90-degree angle? Let's check. There's your protractor. Does everybody see how that's a 90-degree angle right there? Alright, let's put it right over here. Let's check it. Let's rotate. Take that. Rotate it. Does it fit right in? Does that slide in perfectly right there? It does. So that does make a 90-degree angle. So what did we learn today? What's the new thing we learned today? Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals. And here's some examples. Have a good day.